Let's start solving the paper 2022 October November paper 42. Let's start with the first question. A cyclist is riding a bicycle along a straight horizontal road AB of length 50 meter. Let's start drawing the diagram. This is the horizontal road. Let this be A. Let this be B. So the length of AB is 50 meter. The cyclist starts from rest at A. That means here the initial velocity is 6 meter per second. The initial velocity is 6 meter per second. No, here they mentioned that the cyclist starts from rest. So that means the initial velocity is 0 meter per second and reaches a speed of 6 meter per second at B. So that means when it is at B here, it reaches a speed of 6 meter per second. The cyclist produces a constant driving force of magnitude 100 Newton. So let's write it here. Driving force is 100 Newton. There is a resistance force and the work done against resistance force is 3560. So let us write the work done against resistance force is 3560 joule. So now what we have to find is the total mass of the cyclist and the bicycle. So what we can do is we can use the work energy equation. So the work done by the driving force is equal to the change in kinetic energy plus change in the gravitational potential energy plus work done against resistance force. So what will be the work done against driving force? So we know that work done by driving force will be force exerted by driving force into distance. This derives from work done is equal to force into distance. So FD driving force will be 100 Newton. We already know this. And the distance is 50 meter. So 100 into 50 will give us 5000 joule. So now, instead of work done by driving force, I can write 5000 is equal to delta K plus delta GP plus work done against resistive force. So work done against resistive force I know is 3560 joule. So here I write 3560 joule. And one more thing to mention here is here the height is not changing. If here at A the height is 0, then at B the height is 0 because it is a horizontal road. So and GP is mass into gravity into delta H, change in height. So because change in height is 0, the GP will also be 0. So this entire thing is nothing but 0. So I will erase this also. So this becomes 0. So I can simply write plus 3560. Now let's talk about the change in velocity, change in kinetic energy. So the change in kinetic energy will be final kinetic energy minus initial kinetic energy. Now the formula for kinetic energy is half mv square. So initially, finally, the final mass of the cyclist and the bicycle we have to find out. And the velocity, final velocity is 6 meter per second. So 6 square minus half into mass we have to find out. And initial velocity was 0. So this is 0 square. So anything into 0 is 0. So this entire thing becomes 0. So you can simply cut this out. So delta Ke is half m6 square, which is 18m. So instead of delta Ke here, I can write 18m. So here 5000 is equal to 18m plus 3560. Now this 3560 will go there, which will give us 5000 minus 3560 is equal to 18m. And the 18 will come down upon 18. Now, and now if I put this in the calculator, My final answer, which is the value for m, will be 5000 minus 3560 answer upon 18. So the value is 80 kg. So the mass is 80 kg. Moving to the next question. A particle of mass 0.4 kg is in limiting equilibrium on a plane inclined category. Okay, let's start drawing the diagram. -30° angle, 90. A particle of mass 0.4 kg. So if the mass is 0.4 kg and the formula for weight we know is mg. So mass is 0.4, gravity is 10, so the weight will be 4 Newton. And because the force due to weight always acts downwards, this will be 4 Newton. Now, limit in equilibrium and friction, that means there is friction here. So there is no other force. Now let us resolve this 4 Newton force. So this force will be mg sine theta. So mg sine theta is 0.4 into 10 into sine 30. So this is 4 sine 30. Similarly, the force perpendicular to the slope will be mg cos theta, which is 0.4 into 10 into cos 30. So this is 4 cos 30. Now, because the system is in equilibrium, this downward force needs to be prevented. And in order to prevent this, there will be a force on the right, which will be the frictional force. Now, what they have told us is that the system is in equilibrium. And if the system is in equilibrium, that means the resultant forces is zero. That means no resultant force acts on the object. And we can make another equation for the resultant force, which will be the resultant force is equal to 4 sine 30 minus Fr. Now, what is this Fr? This Fr is nothing but Ur. And what is this R? This R is the contact force, which is this right here. So R is equal to 4 cos 30. So Fr is equal to 4 micro into 4 cos 30. So instead of this Fr right here, I can write 4 cos 30. And instead of this F resultant here, I can write 0. So let me make the changes now. Here I can write 0 and here u 4 cos 30. Now I will take this here. So we will have micro 4 cos 30 is equal to 4 sine 30. Now this will go down. So it will give us upon 4 cos 30. So the answer will be, if I put this in the calculator, so the value for micro is sine 30 upon cos 30. The value is root 3 upon 3. Yes, and our answer is correct. They have told to show that the coefficient of friction is root 3 upon 3. So we have gotten our answer. Let's move to the next question. A force of magnitude 7.2 Newton is now applied directly up a line of greatest slope. Okay. So now we will have to change this Fr. Now this Fr will no longer act upwards. Why? Because there is a new force introduced right here, and that is 7.2 Newton. Given that P starts from rest, find the time it takes for P to move 1 meter up the plane. So now because the particle is moving up, the frictional force will start to act downwards. And what and now there will be acceleration as P starts to move. So what we can say is the resultant force will be equal to 7.2 minus the frictional force minus 4 sine 30. So this frictional force will not change. This will remain u into 4 cos 30. So the resultant force is 7.2 minus, and the value for coefficient of friction we know is root 3 by 3. So this will become root 3 upon 3, 4 cos 30. Minus 4 sine 30. And we also know that F resultant is equal to mass into acceleration. And the mass right here is 0.4. This is 0.4a. So instead of this F resultant here, I can write 0.4a. So 0.4a is equal to 7.2 minus root 3 upon 1 second minus root 3 upon 3 into 4 cos 30 minus 4 sine 30. Now this will go down and this will become the entire thing answer divided by 0.4. So if I put this in the calculator, I will get the value of A, which is acceleration. So the value for acceleration is 1 second. Let me put it in my calculator. 7.2 minus root 3 upon 3 into 4 cos 30 minus 4 sine 30. The entire answer divided by 0.4. So the acceleration is 8 meter per second square. Now that's not we have to find what we have to find out. What we have to find out is the time taken t if we have to move 1 meter up the plane. So what all do we know? We know acceleration is 8 meter per second. We know the distance traveled is 1 meter. We also know that P starts from rest. That means its initial velocity was 0 meter per second. So we even know the initial velocity being 0 meter per second. So what is the only thing that we have to find? T. Now we have ASU. So we can use S equals UT plus half a T square. So therefore S will be 1, U will be 0. So this entire thing becomes 0. So half acceleration is 8, T square we have to find out. So this cancels out to become 1 by 4. Therefore, t square is 1 by 4. So t will be root of 1 by 4. So t is 1 upon 2. So the value for t is 0.5 seconds. And here we have an answer. So that means it takes 0.5 seconds from P to move 1 meter up the plane. Let's move to the third question. A particle of mass 0.3 kg, okay, held at rest by two inextensible strings. One string is attached at an angle 60 degree to horizontal ceiling. One the string attached at angle alpha to vertical fall. The tension in the string attached to the ceiling is 4 Newton. Oh, this is not mentioned in the diagram. So attached to the ceiling, where have they mentioned the ceiling here? The horizontal ceiling. So this is horizontal. This is a horizontal ceiling. So the tension in the ceiling is 4 Newton. So tension will be upwards 4 Newton. Now many of you may have a doubt that how is this upwards? So let me clear it for you. Let's assume I have a pendulum that is attached to a string. And now because this pendulum will have mass, there will be a weight downwards, but still the pendulum remains as it is. It does not move anywhere. That is because tension acts upwards and it balances out the weight. So similarly, in any case, any criteria, if for example, this is the ball and this is the string, so the tension will always be in the direction of the ceiling or whatever it is being supported at. So tension will always be in that direction. So similarly, tension in this spring will be in the direction of the wall. So this is this direction. I hope you have understood. That is how you find the direction of tension. So this is 4 Newton. Let this be the tension value T which we have to find out. So now what do we do? Find the tension in the string which is attached to the wall and find the value of alpha. So first thing we do is we resolve the forces. And what do I mean by resolving the forces? Here you can see this 4 Newton force. I can resolve it by saying that some part of this force will act upwards and some part will act to the right. Now this part to the left. This I can shift it up here and make an arrow like this. Now this forms a 90-degree triangle. Let me redraw the 90-degree triangle here. So this is 4 Newton. This is 90 degree. This is 60 degree. This is yeah. Let this be X and this be Y. So this is the opposite side. This is the adjacent side. And this is the hypotenuse side. Now let me erase all the arrows. And let us find X and Y. So we can use sine. Sine is opposite upon hypotenuse. So opposite is X. Hypotenuse is 4. So this 4 will go there, which will give us 4 sine 60. So 4 sine 60 is equal to X. Similarly, we can use cos. So cos 60 is equal to adjacent upon hypotenuse. Adjacent is Y. Hypotenuse is 60. So again, the 60 will go up. So 60 cos 60 is equal to Y. So this I can erase here. So now we have two equations. 4 sine 60 is equal to X. X is the upward direction. So now I can label this as 4 sine 60. And this direction to the left, I'll bring it here again. And this will be 4 cos 60. Now that I have resolved the forces, I have no requirement of this force. You can directly cancel this out. Why? Because this force 1 and 2 is equivalent to the force 3. So now I have resolved the force upwards and to the left. Now similarly, let me resolve this T Newton force. So one force will act to the right and one force will act downwards. Now I will shift this force here and it will look something like this. So this is what it looks like. Now let me redraw the diagram. Right, down. Yeah, this is 90 degree. This is T Newton. We label this as X. This is angle alpha. We label this as X, this as Y. Again, we can use trigonometry. So sine alpha, this is the opposite side. So this will be X upon T. This is the hypotenuse. So this T will go up, which will give us T sine alpha equals X. So now we know that T sine alpha equals X. Let me rewrite it here. T sine alpha is equal to X. Similarly, let's find Y. Y is the adjacent side, so we can use cos. We can use cos, not sine. We have already used sine. Cos alpha is equal to Y upon T. So this T will go up. T cos alpha equals Y. So let me rewrite that. T cos alpha is equal to Y. Now, this Y is the force that is acting downwards. So this force acting downwards will be Y, and Y is T cos alpha. So this is T cos alpha and this is T sine alpha. Now this, I'll rewrite it here again. So this will become, let me erase this first. This will become T cos alpha. And now I will erase this all. And now I can even cut this. This line is not required anymore because this line 1 and 2 is equivalent to this third line. If I write this T Newton at angle alpha, at this angle alpha, that is equivalent to one force acting to the right and one force acting down. And where the right is T sine alpha and the left is T cos alpha. Both are equivalent to each other. And why did I do this resolving? I will tell you in a while. So the mass is 0.3 kg. So one more force that will act will be the weight. So we know the weight is mg. So the weight will be 0.3 into 10, which is a 3 Newton. So the weight will be 3 Newton. Now let us differentiate horizontal and vertical forces. So horizontal forces and vertical forces. Now which are the horizontal forces? This 4 cos 60 and T sine alpha are the horizontal forces. So let me write it here. 4 cos 60 and T sine alpha. Similarly, which are the vertical forces? The 4 sine 60, T cos alpha, and 3 Newton are the vertical forces. So one upward force is 4 sine 60, and two downward forces are 3 Newton and T cos alpha. Now we know that the system is in equilibrium. How do we know that? No, right. That we do not know. Once you are done, then mention in the string. Yeah, but what can we do now is we can equate the equation. So that means the force, this is the force on the left. It will equal the force on the right. Similarly, this is upward force that will equal the downward force. These two are the downward force. So let's make the equation. So force on the left is 4 cos 60. This will equal T sine alpha. Similarly, 4 sine 60 will equal 3 minus T cos alpha. So I can take this T cos alpha here and 4 sine 60 here. So what I'll get is T cos alpha is 3 minus 4 sine 60. So now we know T sine alpha is 4 cos 60 and we know T cos alpha is 3 minus 4 sine 60. So now what we can do is we can do T sine alpha upon T cos alpha. So T sine alpha is 4 cos 60. T cos alpha is 3 minus 4 sine 60. Now this T will cancel out and sine alpha upon cos alpha will become tan alpha. So therefore, tan alpha equals 4 cos 60 upon 3 minus 4 sine 60. So the answer is minus 4.31. So the alpha value will be tan inverse of minus 4.31, which is minus 76.9 degree. Now what does this minus mean? This minus means nothing but down. So the alpha value will be nothing but positive 76.91 degree. And how do we find the value for t? So we know that t sine alpha is this much. So t will be 4 cos 60 upon sine alpha. And the value for alpha is 76.9. So instead of alpha, I will write 76.9. And so the answer for t will be 4 cos 60 upon sine 76.9, which is 2.05 Newton. So the value for t is 2.05 Newton. So here is our answer. Alpha is 76.9 and T is 2.05. That's what we have to find out. Alpha and T, tension. Now let's go to the fourth question. A car of mass 1200 kg is traveling along a straight horizontal road. Let's start drawing the diagram. A car of mass 1200 kg. Let A be here, B be here. Car of mass 1200 kg. So the mass of car is 1200 kg. It is traveling along a straight road. Constant resistance force of 500 Newton. When the car passes point A, it has a speed of 15 meter per second. That means the speed will be 15 meter per second. And the acceleration is 0.8 meter per second. So that means the acceleration of the car is 0.8 meter per second square. Find the power of the car's engine at point A. Okay. So what we know is power equals force into velocity. Now what is this power? This power is the power of the car's engine. So if there is a power of the car's engine, so there would this F will be the driving force. Why? Because driving force and power of the engine have a relation. Now hear me out. If the engine does some work, if the engine exerts power, then what will be the result of it? Then its result will be there will be some force which will be exerted on this car, and that force will be the driving force. And that force will be the driving force. And don't get it confused with resultant force. The resultant force will be the driving force minus this resistance force, which is 500. So now we have to find the power of engine. We know the velocity at point A, the velocity is 15 meter per second. Yeah. So V is 15. So we can write this much. Power of engine is driving force into 15. Now, how do we find the driving force? First of all, in order to find the driving force, you need to understand that resultant force will be equal to the driving force. The driving force will be ahead. This will be the driving force minus 500 Newton. This N is not required. Now I can also say that resultant force is equal to mass into acceleration. So mass of the car is 1200 and acceleration is 0.8. So the resultant force is equal to 1200 into 0.8. So 1200 into 0.8 is 960 Newton. So the resultant force is 960 Newton. So 960 Newton is equal to the driving force minus 500. So this 500 will go there and will become 500. 1 second. 500 plus 960. So finally, the driving force is equal to 900 plus 960 plus 500 will be 1460 Newton. And we know that power of engine equals driving force into 15. So therefore, power of engine equals 1460 into 15. And if I put that in the calculator, 1460 into 15 will be 21900 watt. So that means the power of the car's engine is 21900 watt. Now let's go to the next question. The car continues to work with this power. Perfect. So power of engine remains 21900 watt. The car takes 53 seconds to travel from A to B. So okay, let's write the power here 21900 watt. And time taken in order to reach from A to B. From A to B, the time taken is 53 seconds. And the speed of the car at B is 32. So that means when the car reaches here, the speed of the car will be 32 meter per second. What else? So we have to show the distance. So what we now know is time taken to travel AB is 53 seconds. we know that the final speed of the car at B is 32 meter per second. From earlier, we know that the speed at A is 15 meter per second. Here we have written it down, 15 meter per second. And we know the acceleration is 0.8 meter per second square. Now what will we do is now we have VB, VA, acceleration and time of AB. So we can use this VA will technically mean initial velocity, U. And this velocity at B will technically mean final velocity, V. So we'll go ahead with that. So we can use S equals half U plus V into T. So S will be equal to half. Initial velocity is 15, final velocity is 32, and time taken is 53. So the answer will be half into 15 plus 32 into 53. So here the answer is 1245.5 meter. But here this is something different. Now why is this different? We could have used this equation if there was no resistance force. But there is also a resistance force of 500 Newton, which in this equation we have not taken into account. So hence we cannot use this equation. So what we will do is we will use a work energy equation. And what is that? That is work done by driving force is equal to delta Ke plus delta Gp plus work done against resistance force. So what is the work done against driving force? We know the power of engine. We know the time it takes. We also know that power equals work done upon time. So power is 21900. Time is 53, which will give us the work done, which is 21900 into 53, which is 1160700 watt, joules. 1160700 joules. So here I can write 1160700 is equal to. Now let's talk about the delta K. Let me erase this. Yeah. So delta Ke will be nothing but final kinetic energy minus initial kinetic energy. So final kinetic energy. So the formula for kinetic energy is half mv square. So final kinetic energy mass is what is the mass? 1200. And final kinetic energy is 32. Initial half into mass is 1200 into initial kinetic energy is 15. Now if I put this in the calculator, the value of delta kinetic energy will be 479,400 joule. So this will be 479,400 joule. And now the interesting thing about delta GP is because this is a horizontal track. So if the height at A is 0 meter, then the height at B will also be 0 meter. So that means there is no change in height. And what is GP? GP is equal to mgh. And if it is delta GP, then it all depends on the change in height, delta h. So the delta h, if the delta h is 0, change in height is 0, then GP, change in GP will also be 0. So this change in GP is 0. And what about the work done due to resistance force? Have they told us? No, but we know that the work done against resistance force is 500 Newton. So the resistance force, which is Fr, which is force due to resistance, is 500 Newton. So what we can do is, we can write work done is equal to force into distance. So work done by resistance force will be resistance force into distance. So we know that resistance force is equal to 900, 500 into distance. Now we have our equation. Now we can easily find the distance d from this. And now notice that we are taking the resistance force in account. So now if I rewrite this, I will get 116,070. Once again, I'll rewrite it a little bit up. 1160700 minus 479400 is equal to 500 D. So this 500 will go down. So if I put this in my calculator, the answer I will get for D, which is the distance of A to B, will be, 1 second, I'll put it in my calculator, 1160700 minus 479400 upon 500, which is 1362.6 meter. So that's what they asked here, 1362.6 meter. The distance is 1362.6 meter. And that's how we end this question. Now let's move to the fifth question. Oh, this is a essay in itself. Interesting question. Let's see. A block of A of mass 80 kg. Let's start making the forces right away. This is 80 kg. So the weight will be 800 Newton. And the force acting parallel to the slope due to the weight will be mg sine theta. Mass is 80, gravity is 10, sine theta is sine 20. So it is 800 sine 20. So this will be 800 sine 20. And connected by a light inextensible rope, block of B mass 40 kg. Okay, so this will be 400 Newton. And the force due to the weight will be mg sine theta again. M is 40, G is 10, sine theta is 20. So 400 sine 20. What more? The rope joining block is taut. Okay. So now there will be this tension force also. T. A force of magnitude 500 Newton inclined at angle 15 degree. Yes, you already know that. Same line of block move up the plane. Okay, so that is important right here. So what we can say is the motion is upwards. And there is a resistance force of 50 Newton on B. Okay, let's make this resistance force. This is the resistance force of 50 Newton on B. This is B, but no resistance force on A. Perfect. So there is no resistance force on A. Now, first thing first, what we will do is we will resolve this 500 Newton force. So how will we resolve? In order to resolve this force, we need to understand that this means one force is acting to the right and one force is acting upwards. So let me redraw the diagram. This is 90 degree. This is 15 degree. So if I redraw the diagram, this is 15 degree. This is 90 degree. And this is a 500 Newton force. Now let me label this line as X and this as Y. Now I can use trigonometry. So sine 15 will be opposite upon hypotenuse. Right here, the opposite side is X. So X upon 50. Now this 50 will go up. It will give me 50 sine 15 is equal to X. So X is equal to 50 sine 15. So, and that is the upward arrow. So the upward arrow is 50 sine 15. Now what about the Y? So this is the adjacent side. So I can use cos 15 is equal to Y upon 50. No, this should be 500. Okay. So this should be upon 500. This will go up and become 500, not 50. So when this will become 500, Which is 500. This goes up. This becomes 500. So this line is 500 cos 15. Now, this upward line, which is 500 sine 15, let me draw it here. 500 sine 15. And now this 500 is of no use to us because we have already resolved the forces. This 500, we have resolved it in terms of x and y, and that is equivalent to this 500 Newton force. So, 1 second, I will clear out everything and write it in a neat manner. So this will be 500 cos 15. The question is to find the acceleration of the block and the tension in the block. So how will we find the acceleration? So let's first write down all the forces on A. So what are the forces on A? So first thing we have to realize is the motion is upwards. So whatever arrow is upwards will be positive and whatever arrow is downwards will be negative. So this 500 cos 15, then 800 sine 20 and this T. These are the three forces that are acting parallel to the slope on A. So 500 cos 15 minus 800 sine 20 minus T is equal to the resultant force. Now we know that the resultant force is equal to the mass into acceleration. So the mass of A is 80 kg and acceleration we don't know. So instead of resultant force here, what I can write is 80A. So I'll do that now. 80A. So this is my first equation. Now let me write down the forces on B. So this T Newton, 400 sine 20 and the 50 Newton. These three are the forces on B. And the T Newton is upwards. So T will consider positive. So T minus 50 minus 400 sine 20 is equal to the resultant force. And now again we can write that resultant force is equal to mass into acceleration. The mass of T is 40 kg. Sorry, the mass of B is 40 kg into acceleration. So instead of this resultant force here, because I have found out the resultant force, I can write 40A. So I'll write 40A now. And this is my second equation. Now let me write both the equations again. So the first equation is 500 cos 15 minus 800 sine 20 minus T is 80A. Now what I'll do is take T there. So, and I'll write this part of the equation first. So 80A plus T is equal to 500 cos 15 minus 800 sine 20. So this is done. This is our first equation. Now going to the second part. Now I will take 40A there and minus 50 and minus 400 sine 20, I'll shift to the right. So in my second equation, T will remain as it is. 40A will move to the left, which will become minus 40A. And this will equal 50 minus 50 and minus 400 sine 20 will go to the right side of the equation. Hence the sign will change and become plus 50 plus 400 sine 20. Now, as you can see, this is a quadratic equation. If I just rearrange this, if I take t to the right and minus 40a to the left, so minus 40a plus t. Now, as you can see, a and t, these both are a part of simultaneous equation. So now I will solve this simultaneous equation. So Yeah. So I'll have to go to more setup, then phi equation, and go to the first one, which is ax plus by plus c. Now inputting minus 40. Sorry. First I input 80. 81 and 500 cos 15 minus 800 sine 20. Minus 800 sine 20. Then minus 40. 1 50 plus 400 sine 20. 50 plus 400 sine 20. And now I'll put equal to. So the value for acceleration is 0.188. Value for acceleration is 0.188. These are our answers. And the value for t will be 194.3. So the value for t is 194.3 Newton. So what we have to find is the acceleration and the tension. So we found out the acceleration and the tension, and we are done with this question. Next, find the time it takes for the block to reach a speed of 1.2 meter per second from rest. So that means from rest means initial velocity is 0 meter per second. The final velocity is 1.2 meter per second. The acceleration of the block will be 0.188 meter per second. 0.188 meter per second. So now we have to find out the time. So I can use the most basic kinematics equation. V is equal to u plus at. So velocity is 1.2, initial velocity is 0, acceleration is 0.188, and time is t. Therefore, 1.2 equals 0.188 t. Now this 0.188 will go down there. This is equal to t. So therefore, the time taken is equal to 1.2 upon 0.188, which is 6.38 seconds. So the time it will take is 6.38 seconds. And is there a, yeah, and we are done with this question. So now we'll move to the sixth question. But 1 second. Yeah, let's start. This is a pretty lengthy question. 5 marks to 7. 7 plus 2, 9. 9 mark question. Okay. And this is, I guess, about collides. This is about collision, momentum. Three particles A, B, C, mass 0.3, 0.4 m, lie in a straight line, horizontal plane, distance BC is okay. Let's start drawing the diagram. And let's draw it here only in the additional page. Down. Yeah. So A, B, C. This is A. This is B. And this is C. This is our first diagram. So the mass of A, what was written there was, the mass of A is 0.3 kg. The mass of B was 0.4 kg. And the mass of C was not given, mkg. Now they have told that the distance between B and C is 2.1 meter. So the distance between B and C is 2.1 meter. Now the next thing they have mentioned is A is projected directly towards B with a speed of 2 meter per second. So A is projected towards B with a speed of 2 meter per second. After A collides with B, the speed of A, okay. So now a collision occurs. So let's make the second diagram. The second diagram will be the diagram of the collision. So how will the collision occur now? This A will travel here and A will reach here, A. And now A and B will collide. And this C does not have any effect. C remains here. And this distance still is 2.1 meter. And after this collision, what happens is, after this collision, A and B. After A collides with B, the speed of A is reduced to 0.6. That means the speed of A becomes 0.6 meter per second. And what else have they told us? And it is still moving in the same direction. Okay. And now even B will start to move. So the question is to show that the speed of the collision, speed of B after collision is 1.5. So we have to find the speed of B after the collision. So now what we can do is we can use momentum and we can write initial momentum equals final momentum. I'm just writing the initials here, IM, FM. But in the exam paper, you'll have to write the entire thing, initial momentum or equals final momentum. But you can also write total momentum before equals total momentum after, anything works. So the initial momentum will be the mass of A, which is 0.3 into the velocity 2. So the initial momentum will be 0.3 into 2. And the final momentum will be mass of A into velocity of A. Mass of A is 0.3, velocity of A is 0.6, plus mass of B, which is 0.4 into velocity of B. Velocity of B we have to find out. So the initial momentum is equal to the mass of A into the initial velocity of A. And the final momentum is equal to the mass of A into the final velocity of A plus mass of B into the final velocity of B. So mass of A is 0.3. This is 2 meter per second. Mass of A will be 0.3. Velocity is reduced to 0.6. Mass of B is 0.4. Velocity of B we have to find out. So 0.3 into 2 is 0.6. 0.3 into 0.6 is 0.18 plus 0.4 into velocity of B. So this can go there, and what we will have is 0.6 minus 0.18 is 0.4 into velocity of B. So the velocity of B, we can take 0.4 down, and this will exactly be the velocity of B. So the velocity of B is equal to 0.6 minus 0.18 minus upon 0.4. Therefore, the answer for the velocity of B will be equal to 0.6 minus 0.18 answer upon 0.4. So the answer is 1.05 meter per second. And that's what we have to show, that the speed is 1.05 meter per second. Going to the next question. After the collision between A and B, B moves directly towards C. Let's update our diagram now. We know that B is directly moving towards C. We have already drawn that. 1 second, we have not drawn C here. And what else have they mentioned? B moves directly towards C. Particle B now collides with C. Okay. So particle B now collides with C. So let's make the fourth diagram. So as this is moving ahead, as B moves ahead, because A has velocity, A will also move ahead. So if A collides here, then A will also move some part ahead. So let's consider A to be here now. A, and it is still moving at 0.6 meter per second. And 1 second, let's not write here. This will be 0.6 meter per second. And B and C collide here. B and C. B collides with a speed of 1.05 meter per second. And C is at rest. Now what they have told is, 1 second, we'll have to go up again. What they have told is, after this collision, the two particles coalesce. The two particles means B and C. And what does coalesce mean? Coalesce means stick. So stick and have a combined speed of 0.5. Okay. So that means this collision occurs here. And after that, after this collision occurs, A, this is 0.6. After B and C collide, they form a single particle D. They stick together and form a single particle D, and that moves at a speed of 0.5 meter per second. And now the question is to find M. And what is M? M is the mass of C. So again, we can use initial momentum equals final momentum. Initial momentum is equal to final momentum. I am writing initial Im equals Fm here. But what you will have to write in your exam paper is initial momentum equals final momentum in whole words. Or you can also write total momentum before equals total momentum after. So initial momentum equals final momentum. And what will the initial momentum be? The initial momentum, because B and C are colliding now. So we only need to consider the momentum of B. So the momentum of B will be the initial momentum, will be the mass of B into the velocity of B. And what about the final momentum? The final momentum, we know that B and C are sticking together. So final momentum will be mass of B plus mass of C, the whole in bracket, into the new velocity. The new velocity is 0.5. So let's write it here. Initial momentum is mass of B into velocity of B. The final momentum is mass of B plus mass of C into the new velocity. So mass of B, did we find out mass of B? No, we already know mass of B is 0.4. So 0.4 into velocity of B is 1.05 is equal to mass of B is 0.4 plus mass of C we don't know, and velocity is 0.5. So this 0.5 I can take it down here. So this will become upon 0.5. So this 0.4 equals this will occur. And this 0.4 we can take it to the left. So this will become minus 0.4. So hence we have found the mass of C. The mass of C, if I put this in the calculator, 0.4 into 1.05, answer upon 0.5. Answer minus 0.4. So the mass of C is 0.44 kilogram. Now let's move to the C question. Find the time that it takes from the instant B and C collide until A collides with the combined particle. Now understand what is happening here. Let me erase this first. And I guess this will be our last diagram. So now you can see that A is traveling at 0.6 meter per second and B is traveling at 0.5 meter per second. So now what will happen is, because the velocity of A is greater than the velocity of D, eventually what will happen is A will collide with D. A will collide with D. Understand this, because this has a greater speed. So eventually it will come closer, closer, closer and collide. So now what we have to find out in the question, what they have asked us to find out is the 1 second. In the question, what they have told us to find out is that from the instant B and C collide, that means this, considering this has time t equals 0, or assume that when B and C collide, you have a stopwatch in your hand and you just start that stopwatch at during that time. You press start when B and C collide. So what we have to find out is, if this is time 0, how much time will it take for AD to collide from this time? So now how will we do that? We can't use IM, initial momentum equals final momentum. We will have to use something else. We will have to now use this data. This is 2.1 meter. So earlier this was 2.1 meter. Now what happened was VB, we know the velocity of B became 1.05, and this distance BC is 2.1. This distance BC 2.1 meter. So first let's calculate how much time taken for B to reach C. That will be time equals distance upon speed. Distance is 2.1, speed is 1.05. So the time, if I put this in the calculator, will be 2 seconds. So that means B took 2 seconds to reach C. And now let's calculate distance traveled by A in that 2 seconds. So the formula for distance is speed into time. So the speed of A is 0.6 and time is 2. So distance traveled by A is 1.2 meter. 1.2 meter. So that means initially this was 2.1. So assuming A was here, that means it covered a total distance of 2.1 meter. So now what, not 2.1, sorry, 1.2. So now what is the remaining distance? What is the remaining distance? So this entire will be 2.1 and this much is 1.2. So the remaining distance will be 2.1 minus 1.2, which is 0.9. So this distance right here from this point to this point is 0.9 meter. Now what happens is, so this distance is 0.9 meter. So now what happens is, what we will have to find out is that if A wants to catch up to D, so the distance traveled by A should be equal to, obviously should be equal to the distance traveled by D and an additional 0.9 meter. And what will be the distance traveled by A? The distance traveled will be velocity into time. Velocity is 0.6. Time we have to find out. And distance traveled by D will again be velocity into time. So what is the velocity of D? D is 0.5. Time is T plus 0.9. So this will go there. So 0.6T minus 0.5T is 0.9. So 0.1T is 0.9. Therefore, the time taken is 0.9 upon 0.1, which if I put in the calculator, is 9 seconds. So 9 seconds is not the answer. 9 seconds is the time it takes for A to reach D. But what about the time taken for BC to collide? What the question has asked is to find the time taken as soon as BC collides. So once this BC collides, this has to cover 0.9 meter. Yeah, so that is our answer. So that means when BC collided, the stopwatch the stopwatch started ticking. And this is when the time was equal to 0 in our stopwatch. And after we found that out, the time is 9 seconds for A to reach D. Because when BC collided, at that instant itself, BC became D. And in order to A to reach D, it took 9 seconds. So the final answer is 9 seconds. So all the working is already done there, but let me do it right away. Let me do it. But should I do it again? Because I have already done it in the diagram. I don't think so. I need to do it again. So what I can write here is done on additional page 12. Yes. Now let's move to the seventh question. A particle P travels in a straight line starting from rest from a point O. The acceleration of P at time t seconds after leaving O is denoted by a meter per second. It starts at rest. So that means the initial velocity is 0 meter per second. And we are given find the velocity at t equals 4. So we have to find the velocity. Now right here we have the acceleration time graph. And from the acceleration time graph, if we want the velocity time graph, what we will have to do is we will have to integrate the formula. And in order to integrate, velocity will get by integrating acceleration, and that is integral of 0.3 t raised to 1 by 2 dt. So if I integrate this, I will get 0.3 t raised to 1 upon 2 plus 1 answer upon 1 upon 2 plus 1. So 0.3 t raised to 3 upon 2 answer upon 3 upon 2. Now this 2 will go up and multiply, and this 0.3 and 3 will cancel out to become 0.1 and 1. So finally we will be left with 0.1 into 2 t raised to 3 by 2. Now time should be equal to 4. So velocity will be equal to 0.1 into 2 t raised to t will be 4. This will be 4 raised to 3 by 2. So the answer for velocity, if I put this in the calculator, 0.1 into 2 into 4 raised to 3 by 2. That is 1.6 meter per second. So that means the velocity of P at time 4 is 1.6 meter per second. Moving to the next question. It is given that there is no change in velocity of P at t equals 4. Okay. That means if from here at the end t equals 4, here t equals 4, the velocity will remain the same. If we integrate this and find the velocity will remain 1.6 meter per second. And the velocity of P at 16 is t meter per second. That means when time equals 16 seconds, the velocity is 0.3 meter per second. Show that k equals 26 and find an expression in terms of t to find the velocity of P. Okay, so let's start integrating this equation. So first let's write the equation a equals kt minus, okay, a equals minus kt raised to minus 3 by 2. So in order to find the velocity time graph, we'll have to integrate the acceleration time graph, which will be the integration of minus kt raised to minus 3 by 2 dt. Now what we can do is we can shift this minus k outside as it is a constant. So minus k integral kt. If you did not understand what did I do, what I technically did was, let me give you an example. If I tell you to integrate 3t, what can you do is you can take 3 outside and just integrate the t. So the final answer you'll get is 3t square upon 2. And if you integrate simply by this also, then also you'll get the same answer, 3t square by 2. So that's what I meant by taking it out. We can take constants such as 5, 6, 5 by 3, minus 2 outside, and the answer won't change for integration. But it should be multiply some constant number into the variable t. If it is k plus t, then we can't take it out. Now moving forward, we can integrate t raised to minus 3 by 2 by into t raised to minus 3 upon 2 plus 1 answer upon minus 3 upon 2 plus 1. Therefore, velocity is minus k t raised to minus 1 by 2 answer upon minus 1 by 2. Now this 2 will go up and this minus will cut to become plus. And what additional will be plus c. Never forget the plus c while integrating. So b equals k t raised to minus 1 by 2 and this 2 went up to become 2 kt. So 2 kt raised to minus 1 by 2 plus c. Now what do we know is that at t equals 4, velocity is 1.6. So when t equals 4, velocity is 1.6. And also the other thing we know is when t equals 16, the velocity is 0.3. When t equals 16, the velocity is 0.3. So now let us input this here. So velocity is 1.6. So 1.6 is equal to 2k. T raised to minus 1 by 2 will become 4 raised to minus 1 by 2 plus c. Now if I put this in the calculator, 4 raised to minus 1 by 2 is equal to 1 upon 2. So instead of 4 raised to minus 1 by 2, I can write multiplied by 1 by 2. Now this 2 will cancel out to become 1. So this is nothing but k plus c. So 1.6 is equal to k plus 6. This is our first equation. Now going to the second part. When t is 16, v is 0.3. So 0.3 is equal to 2k. T raised to minus 1 by 2 is 16 raised to minus 1 by 2 plus c. So 16 raised to minus 1 by 2 is 1 upon 4. So instead of 16 raised to minus 1 by 2, I can write 1 upon 4. Now this will simplify to become 1 upon 2. So that is k by 2. So now I have two equations. And if you realize these are simultaneous equations, so let me rewrite it. K, not this pen, some other ink. Yeah. K plus c equals 1.6. K upon 2, which is 0.5k. 0.5k plus c is 0.3. Now we'll put this in the calculator. Shift mode, equation, and 1. So 1, 1, 1.6, 0.5, 1, 0.3. So the value for k is 2.6 and the value for c is minus 1. So the value for k is 2.6, the value for c is minus 1. Now what they have told us to find is that to show that k equals 2.6. So we showed that, and we have to find an expression. Now what expression? The expression for velocity for p to 14. So this we have to integrate to velocity time graph. So we have already gotten this here. This is the most simplified form. This is velocity equals 2k t raised to minus 1 by 2 plus c. But this plus c we found out right now is minus 1. So instead of this c, we will write minus 1 right here. And instead of this k, we will write 2.6. So v is equal to 2 bracket 2.6 into t raised to minus 1 by 2. So if I put 2.6 in the calculator, this becomes 5.2. So v is equal to 5.2 t raised to minus 1 by 2 minus 1. So that's our expression. Now let's go to the C question. Given that t comes to instantaneous rest at t equals t, find the exact value of t. Now this capital T comes in this equation. And if I integrate this, this is the answer which I get. So let me rewrite it. V equals 5.2 t raised to minus 1 by 2. 5.2 t raised to minus 1 by 2 minus 1. So instantaneous rest means velocity is 0. So 0 equals 5.2 t raised to minus 1 by 2 minus 1. This minus 1 goes there and becomes plus 1. So 1 equals 5.2 upon this. So 5.2 will go down. So become upon 5.2. And this t raised to minus 1 by 2 is left. Now t raised to minus 1 is nothing but 1 by t. So what I can write is 1 upon 5.2 is equal to 1 upon t raised to 1 by 2. and t raised to 1 by 2 is nothing but root t. So 2 raised to 1 by 2 is root t. So this will go up and this will go up. At the end, we'll have root t equals 5.2. And this root will go there and become a square. So t is 5.2 square. So the exact value of t will be 5.2 square, which I put in the calculator, and I'll get 27.04 second. So the answer is 27.04 second. Now going to question D. Find the total distance traveled between t equals 0 and t equals t. So now for that, let us first make the equation of the velocity time graph. So initially, this is 0.1 into 2 into t raised to 3.2, which is v is 0.2 t raised to 3 by 2. So this will look something like this. And this is till t equals 4. And at t equals 4, velocity is 1.6. So when t equals 4, velocity is 1.6. Initially, it is at rest, so it will start from 0. So initially, the graph looks something like this. And then what happens is v becomes 0 at 27.04 seconds. So exactly at 27.04 second, v becomes 0. So now there are two equations for this. First one is 0.2 t raised to 3 by 2. For the first region, we will have to integrate 0.2 t raised to 3 by 2. And for the second region, it will be integral of this 5.2 t raised to minus 1 by 2 minus 1 dt. And what will be the limits? The limits for the first one will be 4 and 0. And the limits for the second one will be 27.04 and 4. So the displacement is integral of 4, 0, 0.2 t raised to 3 by 2, which is 0.2 t raised to 3 upon 2 plus 1 upon 3 upon 2 plus 1, and this will be 4 and 0. Now if I put this in the calculator, 0.2 t raised to 3 upon 2 plus 1. Let me simplify it first actually, because I will get marks for that. So the displacement will be 0.2 t raised to 5 upon 2 0 upon 5 upon 2. So this 2 will go up, which will give us 0.4 t raised to 5 upon 2, because 2 into 0.2 is 0.4 upon 5. This is 4 to 0. So now if I put this in the calculator, 0.4 t raised to 5 upon 2 upon 5. If the value is 4, it is 2.56. And if the value is 0, it is 0. So that means distance traveled between time 0 to 4 seconds. 1 second, write it in a better manner. In time 0 to 4 seconds, the distance traveled or the displacement is 2.56 meter. And now let's integrate this part. 27.04, 4, then 5.2 minus 1 by 2 minus 1 dt. So now displacement is equal to 5.2 t raised to minus 1 by 2 plus 1 answer upon minus 1 by 2 plus 1 minus 1 into t. And this limits will be 27.04 and 4. Further simplifying this will give me 5.2 is to t raised to 1 by 2 answer upon 1 upon 2 minus t. And this will be 27.04 and 4. Now this 2 will go upward and 5.2 into 2 will become 10.4. So t upon 1 from 10.4. So now the bit for time 4 to 27.04, the displacement traveled will be 10.4 into t raised to 1 by 2 minus t. If I put 27.04, the answer is 27.04 itself. Minus, if I put 4, the answer will be 16.8. So the total distance traveled, I will write it here itself. Total distance traveled is equal to the distance covered in the in the orange region is 2.56. There's this time between 0 to 4. So 2.56 and the distance traveled between time 4 to 2.04 second is 27.04 minus 16.8. If I put that in the calculator, 27.04 minus 16.8, that will give me 10.24 second, 10.24 meter. So distance traveled in this region is 10.24 meter. So total distance is 2.56 plus 10.24 and the answer is 2.56 plus 10.24, which is 12.8 meter. So the total distance traveled is 12.8 meter. And that's how we end this question and we also end this paper. Thank you for watching.